Okay, this one is the classic calculus problem. In calculus, what you spend a lot of time doing is maximizing or minimizing in calculus. And all these people that do calculus as minds, this is what every farmer is thinking about. So here we have a rectangular pen that is bordered on one side by a barn, on the other three sides by 400 meters of fencing. The area of the lot is the maximum, find the area. So I'm just going to draw this. Instead of a let statement, if you have something you can draw and you can draw it, that counts as a let statement too, because whoever's looking at it or marking it can see your variables from your drawing. So just make sure you label it. So this red one is my barn. So here's the barn, and one side of the barn is going to be part of the bordered area, and then the other three sides have fencing. So I'm going to go fence, 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 and I know I got 400 meters of fencing. Area is a maximum. Let's see. Well, I'm going to call, because we're going to find area and it's a rectangle, I know area of a rectangle is length times width. So I'm going to call this my length, which this, because it's a rectangle, the length on top is the same as the length on the bottom. And then on the side, this is my width. Okay. Because there's 400 meters of fencing, I know that 2L plus 1W adds up to the 400 meters because you don't need to fence the barn. The barn's going to block any animals. And if you want to have fun, you can always draw some pigs or something in there. Eek, that's a pretty sad pig. So I get 2 lengths plus the width equals 400 meters. What we're trying to maximize again is the area. So basically in this area formula, we're going to use this 2L plus W equals 400 and sub in for either L or W. So you got to isolate one of L or W. And in this case, because W doesn't have a variable attached to it, it's easier to isolate W. So I'm just going to subtract 2L from both sides of this equation. And I get W equals 400 minus 2L, and then I'm going to sub it in here for W. So we get a formula for area, which we're going to try to maximize, equals L times 400 minus 2L. Again, just like the first question, you can expand this, put it in the right order, and then complete the square. But I think it's easier. I'm just going to graph it on Desmos. So what I'm going to graph is y equals x times 400 minus 2x, and then I'm going to find the vertex. If you're doing it on your graphing calculator, the window's going to be huge. So one tip for the graphing calculator is that when I look at this pen, because there's 400 meters of fencing and there's 3 sides, probably the most you could have for one side, like kind of try to figure it out. The most I could have for one side, if it's the length, is maybe 200 meters, because you could have one side 200, the other side 200, and then the width, you got nothing. So you basically got a flat line, and you got 0 area because it's right on top of itself. But how that helps is if you can figure out what the biggest possible x value is, because we're graphing in terms of x, then on the window, set your x minimum as 0, because you can't have a length smaller than 0. The x max is 200. But then after you set those two, press zoom 0 and zoom 0. As long as you set your x values, zoom 0 tries to get the best y value for those x values, and hopefully you'll see the maximum. So now I'm going to go to Desmos and graph this. So I'm graphing y equals x times 400 minus 2x. And you can tell, I really don't see anything, but I'm just pinching this, making this, oh, I'm starting to see it come down. There we go. Let's go. Now I'm just pulling across on the x-axis. And then this 0 to 200, if you look at the x-intercepts, you can actually see them. That's what I was talking about. that you could have an x minimum of 0, x maximum of 200, and then the graphing calculator tries to get the maximum in. But those points aren't what we're looking for. What we're looking for is this vertex, 100, 20,000. So we will take that. So the vertex is 100, 20,000. What you need to remember is it's actually from here, not from this. And that tells me that this 100 is a length, okay? This is the maximum area, and that's what we're looking for this time. So the question asks, find the area. Well, we can answer it. The max area is 20,000 meters squared. Because it was 400 meters of fencing, that's why I know it has to be in meters squared. If you want to figure out, well, what does this really mean? Take this 100, sub it in here, and we'll get the width. And you can go, okay, the width is 400 minus 2 times 100, which is 400 minus 200 is 200 meters. So basically, we got a pen that is 100 meters by 200 meters. And it gives you that max area. So we didn't have to find this, but this is just showing you where the info comes from.